Okay, we are changing our production facilities here. So this is about convergence with endpoints. So if we look at e to the x, 1 plus x over 1 factorial plus x to the n over n factorial, written in sigma notation as x to the n over n factorial. I test first, setting up my limit nice and cleanly, n as goes to infinity of the absolute value of x to the n plus 1 over n plus 1 factorial times n factorial over x to the n. This is testing for absolute convergence because I have the absolute values around them. That collapses down to x over n plus 1, which equals 0. Therefore, it's going to converge for all reals. I don't need to test any endpoints. But now let's look at the Taylor polynomial for ln of 1 plus x, which you can get in two different ways. My way would be doing the geometric series expansion of 1 over 1 plus x and then integrating both sides. So you end up with x minus x squared over 2 plus x cubed over 3. Alternating series, so I got negative 1 to the n plus 1 times x to the n over n. Set up my limit as n goes to infinity of the n plus first term divided by the nth term, which works out to this. The negative 1's go away. I end up with x times n over n plus 1, but this is going to go to 1. So my limit is equal to the absolute value of x, which I then bound less than 1, which leads to negative 1 is less than x is less than 1. So since I was testing for absolute convergence here, it absolutely converges on this interval. But now I independently test the endpoints. So with x equals 1, I go back and I generate what that equals: 1 minus 1/2 plus 1/3 minus 1/4, which you should all recognize as an alternating harmonic series. The terms are going to 0, 0. Therefore, you can say it converges. When I set x equal to negative 1, carefully putting it in, I get negative 1 minus 1/2 minus 1/3 minus 1/4 minus 1/5. That is going to diverge. That is the negative of the harmonic series. So it converges at 1, but not at negative 1. So my final interval of convergence is negative 1 is less than x is less than or equal to 1. However, the convergence at 1 is conditional because it's an alternating series. If I turn this positive, it will diverge. So if you're asked, where does this absolutely converge? On this interval. If you're asked, where does it converge at all? It's this interval. And if you're asked, where does it conditionally converge? At x equals 1 only. That's it. Over and out from the new production facilities. Let me see.